Hi there and welcome to another video for revision for the Edexcel Core 3 Maths A-Level syllabus. In this video we're doing the third video on differentiation, and these are the exam questions that have come up that ask you to work out tangents and normals to curves using the technique of differentiation. As always, take a look at the question, pause the video, try it, and then work through my solution and check your work against it. First question. Okay, it wants us to find the equation of the tangent to this curve here at the point x is 0, y is pi by 4. It wants us to give our answer in the form y, some number times x plus some number. A and b have to be stated at the end. Now notice with this question, x is the subject of the formula. When x is the subject of the formula, you know from your differentiation work that you're going to have to use the fact that dy by dx is 1 divided by dx dy. That is your hint for this question, because x is the subject of the formula. You're going to have to differentiate everything with respect to y and then take the reciprocal of that to get dy by dx. Okay, so let's do that. Let's work out dx by dy, differentiating everything here. So this is the equation we have. Differentiating with respect to y, we use the chain rule here. The differential of this bracket with respect to y is 2. The differential of cos is negative sine, and you keep the bracket as it is, 2y plus pi, which is simply negative 2 sine 2y plus pi. Okay, now that's dx by dy. If you want dy by dx is therefore 1 over this. So dy by dx is simply 1 over negative 2 sine 2y plus pi. And we've got our dy by dx now. Now, in order to get the gradient of the tangent, you need to know the equation of the tangent. You need the gradient of the tangent and a point on the line. Well, here's a point on the line, so we've got that. We just need to know what dy by dx is when x is 0, but our dy by dx isn't in terms of x's, so when y is pi by 4. So we work out dy by dx when y is equal to pi over 4, and we substitute that in. And substituting that into your calculator, y is pi by 4, and your calculator in radians mode, you should get the answer that dy by dx at that point is a half, i.e. the gradient's a half. Okay, so let's just continue it there. We want to find the equation of this tangent, so we're going to use the formula y minus y1 is equal to mx minus x1. Remembering that m here is the gradient, and x1, y1 are a pair of coordinates that lie on this particular line, which is a tangent. So we know this lies on the line, so we could say simply y subtract pi by 4 must equal m, which is a half, x subtract 0. So therefore y minus pi by 4 is a half x. That's the equation of the tangent. They want it in this form with y the subject, so y is equal to a half x plus pi by 4. What are our a and our b? Our a is simply a half then, and our b is simply pi by 4. And we're done, and we've got ourselves our 6 marks. Okay, next question. Okay, let's work through this. For part A, we're told that a point P lies on this curve, and the y coordinate of P is 8. Find in terms of Lune 2 the x coordinate. You know that 8 is on that line. So you must know that 8 is equal to 4e to the 2x plus 1. So you can divide both sides by 4. And you would get 2 is equal to e to the 2x plus 1. This is the point you would take the natural logarithm of both sides. So Lune 2 is equal to Lune of e to the 2x plus 1, at which case you can bring down the power 2x plus 1. and you could say that Lune 2 is equal to 2x plus 1 Lune e. Well, you know that Lune e is equal to 1, so therefore Lune 2 is equal to 2x plus 1, and rearranging this to find x is therefore, you subtract 1 and halve it, so Lune 2 subtract 1 over 2. This is the x coordinate of P in terms of Lune 2. Do not work it out. It asks you to leave it in terms of Lune 2. Don't type that in your calculator and do any sort of rounding. Leave it in terms of Lune 2. Equivalently, this could have been a half Lune 2, subtract a half, dividing both of these by the 2 is equal to x. So there we go. Next part. Find the equation of the tangent to the curve at P in the form y is equal to ax plus b, where a and b are exact constants to be found. Very important here, where a and b are exact constants. That means don't round to decimal places. Leave them in surd form or in Lune form or whatever form is needed, but do not round them. So we want to find the equation of the tangent to the curve at P. Just going back, let's write down our equation. Y is equal to 4e to the 2x plus 1. Here's our curve. Y is equal to 4e to the 2x plus 1. And the point P we found is half Lune 2 minus 1 over 2. So P is Lune 2 subtract 1 over 2, 8. And we want to find the equation of the tangent there. So we know a point on that tangent here, which we can substitute in. We need the gradient of the tangent. So of course we need to work out dy by dx. It's going to be the differential of this up here. Now remember the rule for differentiating exponentials. If you have a function y is equal to e to the f of x, then dy by dx is the differential of the exponent f dashed x multiplied by e to the f of x. So keep the 4 here where it is. The differential of this is 2, and then keep e to the 2x plus 1, and we're simply going to have 8e to the 2x plus 1. Okay, so that's our dy by dx. Now we want to work out our dy by dx at the point P, so for x is equal to this. So we're going to substitute x is equal to that in. So we're going to substitute x is equal to Lune 2 subtract 1 all over 2. And what are we going to get? Well, we're going to get 8e to the 2 times this. Well, Lune 2 minus 1 is being divided by 2, so then we're going to times it by 2. So we're simply going to get Lune 2 subtract 1 for the 2x, and then we're going to add the 1, which is this one here. Tidying that up, you get 8e to the Lune 2, and e to the Lune 2 is 2, so you get 16. And that is your gradient. Now you want to work out the tangent, and you've got your m, and you've got a point on the line here. So you're going to use y subtract y1 is mx subtract x1. Y subtract 8 is going to be equal to 16. X subtract this, so x subtract Lune 2 subtract 1 over 2. And we can multiply by the 16 just to tidy up. Y subtract 8 is 16x. 16 times this, well the 16 times a half is 8, so you get subtract 8 Lune 2 subtract 1. Y subtract 8 would be 16x, subtract 8 Lune 2 plus 8, and then adding 8 to both sides, y would be equal to 16x, subtract 8 Lune 2 plus 16. And that is the equation of your line. What is your a and your b? Well, your a is 16, and your b, the number part, is equal to this, which is equal to 16 subtract 8 Lune 2. And you're done. Okay, next question. Right, let's go through each part bit by bit. The first part, you're told that y is log base a of x, where x is bigger than 0 and a is a positive constant. Express x in terms of a and y. So make x the subject of the formula here. Logs sometimes confuse people, but if you remember that 2 to the 3 is equal to 8, and the equivalent statement to that, 2 is always your base number, it's on the bottom. So that's the equivalent of log base 2 of 8 gives me the answer 3. That's the opposite of doing 2 cubed is 8. Log base 2 of 8 is saying 2 to the power of what gives me 8. So here, applying the same thing, we know for part 1, we're told y is equal to log base 8 of x. And knowing that these two are equivalent here, our base is a, that's the same as saying a to the power of y is equal to x. And there we have x in terms of a and y. That would be x is equal to a to the y, just writing x as the subject of the formula. Then it says deduce that ln x is y ln a. Well, part 2 is very simple. You just take natural logarithms of both sides. So ln x is therefore ln of a to the power of y. And then using log laws, you can bring down the power. So ln x is equal to y ln a. And you've got what you've wanted for the first two parts, nice and easy. Next, show that dy by dx is 1 over x ln a. Well, you have, at this point, ln x, from the previous part, you have that ln x is equal to y ln a, y ln a. And if you differentiated both sides with respect to x, differential of ln x is 1 over x. And the differential of y is dy by dx. And you still have your ln a, because ln a is just a number. So dy by dx as the subject then, divide both sides by ln a, is simply 1 over x ln a, as required. And it was simple. So in part B, you should have been thinking, well, I've worked out this here for no particular reason. If I differentiate both sides with respect to x, I can find dy by dx and make it the subject of the formula. Part C, this curve, y is equal to log base 10 of x, where x is bigger than 0. The point A on the curve has x coordinate 10, so we know that A has x coordinate 10. Always handy to work out what the equivalent y coordinate is at that very point. So if we put x in here and we type in our calculator log base 10 of 10, we get the answer 1. Well, of course we do, because 10 to what power gives me 10? 10 to the 1. Okay, it says using your result in part B, find the equation of the tangent to the curve. So we want to work out dy by dx. Well, we know dy by dx would be equal to 1 over x ln a. We know it would be 1 over x ln a, where a here is going to be 10. Okay, because before we were dealing with log base a. So we know from the previous part that that's 1 over x ln a. But a previously was our base, so this would be 1 over x ln 10. So if we want to work out dy by dx at a particular point, at the point x is 10, we substitute in 10, and that's equal to 1 over 10 ln 10. Okay, and now we've got a point on the line and we've got the gradient. So we use y subtract y1 is mx subtract x1. And we would say that y subtract 1 is 1 over 10 ln 10 x subtract 10. And I mean, that's the answer there. It hasn't asked us to simplify it. We could just say y subtract 1 is 1 over 10 ln 10, and then multiplied by this would be minus 1 over ln 10. If we want it in the form y is the subject, we would therefore say y is, there's an x there, 1 over 10 ln 10 x, and then we would say plus 1, add this 1 to both sides, minus 1 over ln 10. And that might be our y equals mx plus c form, but it hasn't asked for that. So we're done. And then part D, it says the tangent to C at A crosses the x-axis at the point B. Find the exact coordinate. where you cross the x-axis, remember for any line, any curve or whatever, where you cross the x-axis is where y, the y value, is equal to 0. So we are making y 0 in our equation. So what was our equation? It was this here, y is equal to 1 over 10 ln 10x plus 1 subtract 1 over ln 10. And we're going to make y be 0, so we're solving this. Okay, we're trying to find the exact coordinates of x. At this point here, I would subtract 1 from both sides and add 1 over ln 10 to both sides. So I would get 1 over ln 10, subtract 1 is 1 over 10 ln 10x. And multiply both sides by 10 ln 10. So I would get 10 ln 10, 1 over ln 10, subtract 1 is equal to x. And that's the exact coordinate of x. You might be tempted to try and tidy this up. It's not actually asked for in any way, so this is a perfectly acceptable answer. Okay, next question. Okay, part 1. We were asked to differentiate this, so we're asked to differentiate our function y is equal to x squared cos of 3x. Now, you should be aware this is a product. There's one function u, there's your other function v. We're going to differentiate this by the product rule. So we're going to define u to be x squared and v to be equal to cos of 3x. U dashed is therefore 2x. V dashed, well, the differential of 3x is 3. The differential of cos, this is all by the chain rule, is negative sine. And then you keep of your 3x, which is just negative 3 sine of 3x. Then the product rule, remember, says that dy by dx is uv dashed plus vu dashed. Okay, so let's do it. I'm just going to move this over here. Actually, I'll just write it there underneath, and we'll go ahead and we'll work it out. Dy by dx. uv dash, this times this, so it's going to be x squared multiplied by negative 3 sine of 3x plus vu dash 2x cos 3x. And, you know, we could tidy this up to some respect. It's not essential that we do. We could take out a factor of x, okay, and we could just say that that's x, leaving you with a negative 3x sine 3x here, and here leaving with you a plus 2 cos of 3x. And you'd be done. There is your dy by dx, simple. Although that is a valid answer as well. Okay, next part. We want to differentiate this. Well, again, you should realise this is a quotient. We've got a u, a function of x on top, a v, a different function of x on the bottom. So this is a differential of u over v. Now you know, what's your u? Your u is equal to ln of x squared plus 1, and your v is equal to x squared plus 1. Your u dashed is therefore the differential inside the brackets, which would be 2x, over the expression inside the brackets, which is x squared plus 1. And your v dashed would be equal to 2x. And you also know by the, if this is y is equal to this, you know by the quotient rule that dy by dx is vu dashed subtract u v dashed, all divided by v squared. So it's just a substitution game here. Let's go ahead and do it. Dy by dx is therefore equal to vu dashed. So this times this. Well, this times this, well, I'll just write it out first. It'll be x squared plus 1 multiplied by 2x over x squared plus 1 plus uv dash, so that times that, so plus 2x ln x squared plus 1, all divided by v squared, so this squared, x squared plus 1, all squared. Now, handily, that would cancel with that in a multiplication. So the top would simplify somewhat and would just be 2x plus 2x ln x squared plus 1 all divided by x squared plus 1 all squared. And there is your dy by dx. Just notice the tiny mistake here I've made. In the formula, it's a subtract. That should have been a subtract. That should have been a subtract. Just made a small mistake there. That was a subtract and that was a subtract. Because the quotient rule is vu dash subtract uv dash over v squared. I was adding them incorrectly. And that's our final answer. Okay, next. It tells us that a curve has this equation. And it tells us x is bigger than negative a quarter and y is bigger than 0. It says the point P on the curve has x coordinate 2. Find the equation of the tangent to the curve at P in this form, where a, b and c are integers. Okay, firstly, we know P's on the curve. Well, we know P's on the curve, and P is of the form x is 2 and y is something else. So why don't we substitute 2 in here straight away, and we would get the square root of 9, which is 3. So P is the 0.23. That's going to help us. That's probably going to get us a mark. Next, we want to be able to differentiate this to work out the gradient function. So y is this here, but in order to differentiate, write it as a power. So we would write that as 4x plus 1 to the power of a half. So let's differentiate. Dy by dx is therefore, bring down the exponent a half, differentiate the bracket and get 4, keep the bracket as is, and reduce the power by 1, negative a half. Tidying that up, you would get 2, half times 4 is 2, 4x plus 1 to the negative a half. Now you want the gradient at the point x is 2, so the next thing to do here is substitute in the value x is 2 into this differential here, and we would get ourselves 2/3. Typing that in your calculator. Okay, now you should keep working down the page. I'm just going to work beside it for now, but in an exam you should really work down the page. Make sure you do. We now want to find the equation of the tangent. We know the gradient. We know a point on the tangent. We've got everything we need to use this formula. Y subtract y1 is mx subtract x1, where m is the gradient of the tangent and x1, y1 is a pair of coordinates on the tangent. So substituting in here, y subtract 3 is therefore 2/3 x subtract 2. Later on, we know we want a, b and c in terms of integers, whole numbers. We've got 2/3 here. Multiply everything by 3 to eliminate that problem. So 3y subtract 9 is 2x subtract 2. Multiplying out that bracket on the right hand side, we would get 2x subtract 4. They want it in this form equal to 0, so subtract 2x off both sides, plus 3y, and add 4 to both sides, you would get the following, where a is negative 2, b is equal to 3, and c is equal to negative 5. If you had made this side equal to 0, you would have just got them flipped around. You would have got a is 2, b is negative 3, and c is 5. That's correct as well. Okay, next question. Okay, we've got a curve. We're told that x can't be 5/3 because otherwise the bottom would be 0 and we can't divide by 0. We have a point on the curve, P, and we're told that its x coordinate is equal to 2. Find an equation of the normal to C at P in this form. Now, just to recap on what normal is, if this is a curve here, this is gonna be rubbed out in a second. If this is your curve, let's say, and you pick a point, let's say here, and you're working out the tangent to it, there's the tangent, okay, the normal, that's a tangent, the normal at the same point is the line that goes through this point but meets the tangent exactly at a right angle. Okay, and this here would be your normal. And you should remember from C1 knowledge that the gradient of the normal is the negative reciprocal of the gradient of the tangent. In other words, let's call it m of normal. Okay, the gradient of the normal is equal to -1 over the gradient of the tangent. Okay, so the gradient of the normal is the negative reciprocal of the gradient of the tangent. So if I knew the gradient of the tangent was, let's say, 3, I would know that the gradient of the normal is -1/3. If I knew the gradient of the tangent was equal to, let's say, 1/3, I would know the gradient of the normal is -1 over 1/3, which is -3. Another way of looking at it is these two numbers must always multiply to -1. Okay, so with these questions about finding normals, you go about it the same way as you would about finding the equation of a tangent, except for at the end, instead of using the gradient of the tangent, you use the negative reciprocal of that, which gives you the gradient of the normal. Okay, let's go ahead and do this. P has coordinate 2. What's the y coordinate? Well, you substitute in 2 into this equation. So on the bottom, you get 5 subtract 3 times 2, which is 5 subtract 6, which is -1 squared. -1 squared is 1, so you get 3 over 1, which is simply 3. So we've got a mark for finding the y coordinate there, I'm sure. Next thing, you want to work out dy by dx of this. Well, in order to work out dy by dx, you write it in indice form, so this would be y is equal to 3, 5 subtract 3x, all to the power of -2. Then dy by dx, we can do that via the chain rule. Bring down the -2, keep the 3 where it is. Oh, differentiate the bracket here, which would be -3. Keep that 3 exactly where it is. Keep the bracket here as it was, but reduce its power by 1. And this therefore would be equal to -2 times -3 is 6. 6 times 3 is 18, so that would be 18. 5 subtract 3x to the -3. Now, we're asked to work out the equation of the normal here. If we work out the gradient of the tangent at the point x is equal to 2, we sub in 2 here, and what do we get? Well, we get -18. Okay, and now you should work down the page in an exam. I'm just doing this because I've run out of space here. The gradient of the tangent is -18, so the gradient of the normal is therefore 1 over 18, because they must multiply to -1. We know a point on the normal, we know 2 3's on the tangent at that point, so it's on the normal at that point. We know the gradient of the normal at that point. We've got everything we need to use this formula. So y subtract 3 would be 1 over 18, x subtract 2. Multiply both sides by 18, so 18y subtract 54 would be equal to x subtract 2. You want it in this form here. Let's make 0 this side. Subtract 18y, add 54 to both sides, so you would get x, subtract 18y, and -2 add 54 is plus 52. And that is the equation of your normal at the point where a is 1, b is -18, and c is 52. And we're done. Okay, next question. Okay, a long question here. Let's work through it bit by bit. First thing, here's our curve. Here's our domain. And we're told that a 0, 4 is on the curve. So we know if we put x is 0 in there, we get y is 4 out. It asks us to find the equation of the normal to the curve at a. Now, we can firstly use dy by dx to work out the equation of the tangent, and then easily get the normal because it's its negative reciprocal. Once we've got that, we have a point on the line, the gradient, and then we can use the equation of a straight line. So, what is dy by dx? By the chain rule, if you differentiate this here, you differentiate inside the sign and you get 2. So keep the 3 there, differentiate the 2x and you get 2, and the differential of sine is cos, and keep your expression inside the trigonometric function the same. Over here, do the same thing, keep your 4 there, differentiate the 2x and you get 2. The differential of cos is negative sine, and keep your expression inside this the same. And just tidying that up, you would get 6 cos of 2x, subtract 8 sine of 2x. And that is your dy by dx. You want dy by dx at x is 0, so you want dy by dx at the point x is equal to 0. And this would be, if you substitute 0 in here, you would get 6. So you know, therefore, gradient tangent is a 6. Therefore, gradient of the normal is negative 6. Okay, and then you can substitute in. Now again, you should work down the page. I'm going to just work beside to save some space. You're going to use the formula y minus y1 is equal to mx subtract x1. And you know that 0, 4 lies on the line. So y subtract 4 is equal to negative a 6, x subtract 0, which is just x. Just if you want to tidy up, multiply everything by 6. 6y subtract 24 is equal to negative x. And add x to both sides, and you would get x plus 6y subtract 24 is equal to 0. That's probably the neatest way of writing the normal to the curve at that point. And you're done, first part. Next, express y in this form, give the value of alpha to 3 significant figures. This is actually an r cos or r sine method question. So our original function is this: 3 sine 2x plus 4 cos 2x. So 3 sine 2x plus 4 cos 2x. We want to express that function in this form, so we want to make it identical to this form here. Expanding out this side here using the addition formula, you would get r sine 2x cos alpha plus r cos 2x sine alpha. Okay, and you know that's equal to 3 sine 2x plus 4 cos 2x. Okay, looking at just the sine 2x here, we know that therefore 3 must be r cos alpha. So 3 must be equal to r cos alpha. And then separately looking at the cos 2x here, you can deduce that 4 must be r sine alpha. So you can deduce then that 4 must be r sine alpha. As always with these, r is therefore the square root of that squared plus that squared, 3 squared plus 4 squared, and so r is going to be 5. And you also know that dividing these equations, dividing equation 2 divided by equation 1 gives you that tan alpha is equal to 4/3. So alpha must be the inverse tan of 4/3. Now remember, you're working in radians here, so your calculator must be in radians mode, and inverse tan of 4/3 gives you, to 3 significant figures, 0.927 radians, and you're done. So what you can deduce then is, written in this form, you must finish off to express it in that form. Y is equal to 5 sine of 2x plus 0.927. And that is your final answer that you should state at the very end. There you go. Moving on to the next part, part C, it says find the coordinates of the point of intersection of the curve with the x-axis. Find your answers to 2 decimal places. Remember, if you want to find where a curve crosses the x-axis, think of any general curve here. Where the curve crosses the x-axis is where y is 0. The y coordinate is 0. Okay? So, what we're trying to solve is y is equal to 0. Now, we found a new way of writing y, and it's going to be much more helpful solving this is equal to 0 than the original function. So, that is much more helpful to use than the original because it's easy to solve. So, we're going to try and solve 5 sine of 2x plus 0.927 is equal to 0. Divide both sides by 5 and you would get sine of 2x plus 0.927 is equal to 0. Take the inverse sine, so 2x plus 0.927 is inverse sine of 0, and inverse sine of 0 is simply 0. So, let's think where our curve is defined. Our curve is going to be defined between negative pi and pi. Okay, so let's draw this out between negative pi and pi. In fact, let's draw it out between negative 2 pi and pi because we're going to double the range here because at the end we're going to have to halve all our answers. So it's going to look something like this. And we know this point here is pi, this is 2 pi, this is negative pi, this is negative 2 pi. And we know that 0 is an important value here. Here's going to be another important value. Here's going to be an important value. Here's going to be an important value. And here's going to be an important value. Also at the end, because we're going to subtract 0.927 from any of our answers, we should probably just extend it a little bit further to consider that, but we know we're not going to have another 0 there. So, what are 2x plus 0.927? It could equal negative 2 pi, it could equal negative pi, it could equal 0, pi, or 2 pi. So to get x from each of these, you subtract 0.927 and then you halve it. Now the first one would be outside the range, so you would ignore it. The first one would be outside because it would be less than pi. The next one though will be fine, so it would be negative pi, subtract 0.927 divided by 2, it would be negative 2.03, negative 2.03 to 2 dp. The next one would be negative 0.46 to 2 dp from this one. This one here would be pi, subtract 0.927 divided by 2, it would be 1.11 to 2 dp. And the last one, 2 pi, subtract 0.927 and then divided by 2, it would be equal to 2.68 to 2 dp. And there are your 1, 2, 3, 4 answers. Next question. Okay, long question, 40 marks. Let's break it down and do bit by bit. Part A, there's our curve. The point P is stationary point on C. Calculate the x coordinate of P. Well, first thing we need to do is we need to solve for a stationary point f dash x must be equal to 0, and that will help us solve it. So we need to work out f dash x. First of all, let's just write f of x as index form, so x to the minus 1. So f dash x would be the differential of this. We'll keep the 3 out of action. Differential of ln x is 1 over x, and the differential of this is minus x to the minus 2. So this would be 3 over x, subtract 1 over x squared. That is our f dash x. And we're solving this equal to 0. So multiply everything by x squared, let's say, and I'd get 3x, subtract 1 is 0. And solving that, I would get x is equal to a third. That is my x coordinate of P. Okay, show the y coordinate of P could be expressed in this form here. Okay, well we know that the x coordinate is a third, so we know x is equal to a third, so we substitute x as a third into this here. So we're working out f of a third, which would be equal to 3 ln a third plus 1 over a third. Okay, and this would be equal to 3 ln a third plus 3. Now, ln a third is ln 3 to the power of minus 1 plus 3. You can bring down the minus 1 inside a ln, so this would be negative 3 ln 3 plus 3, which is 3 subtract 3 ln 3, where k is 3, this number that we were asked to find. And we're done. The point Q on C has x coordinate 1. Find the equation of the normal. Well, when x is 1, remember what f of x is. F of x is equal to 3 ln x plus 1 over x. So 3 ln x plus 1 over x. The obvious question we need is what is y at that point. So work out f of 1. That would be 3 ln 1 plus 1 over 1. Ln 1 is 0, so this will just be 1. So y is equal to 1. So therefore Q has coordinates 1, 1. We need to work out the equation of the gradient of the tangent at Q, and that will help us work out the gradient of the normal at Q. So we need to work out dy by dx for the function 3 ln x plus 1 over x. So dy by dx, we have looked at this previously. Dy by dx is 3 over x subtract 1 over x squared. So it's 3 over x subtract 1 over x squared. And we want to work out what dy by dx is at the x point 1. So that would be 3 subtract 1, which is 2. Again, you should be working down the page, but I'm working across just to fit it all in one page. You use the formula y minus y1 is mx minus x1, where x1, y1 is a pair of coordinates on the normal, i.e. the points at Q, and m is the gradient of the normal. Well, you know that the gradient of the tangent is equal to 2, so the gradient of the normal must be negative a half. So therefore y subtract 1 is equal to negative a half x subtract 1. Multiply everything, let's say, by 2. 2y subtract 2 is negative x subtract 1. Multiply out that bracket, 2y subtract 2 is negative x plus 1. And maybe if we add x to both sides and subtract 1, we would get x plus 2y and subtract 1, subtract 3 is equal to 0. And that is the equation of our normal 2c at the point Q. Next, D, the normal 2c at Q meets the curve again at the point R. Show that the x coordinate of R is equal to this. So, what is the equation of the normal? The equation of the normal is x plus 2y subtract 3 is 0. So the equation of the normal is x plus 2y subtract 3 is equal to 0. The equation of the curve, you'll remember, is y is equal to 3 ln x subtract 1 over x. We want to find where this normal meets this curve again. We're trying to solve a pair of simultaneous equations, equations 1 and equations 2. So why don't I substitute what I have for y in this equation here in place of y in this equation, and I would get an equation just with x's I might be able to solve. So I would get x plus 2, 3 ln x minus 1 over x, subtract 3 is equal to 0. multiplying out x plus 6 ln x, subtract 2 over x minus 3 is equal to 0. And that is this here. If I just rearrange it, that's 6 ln x plus x plus 2 over x, subtract 3 is equal to 0. I just remembered here that the tiny mistake I did, I wrote down the original function wrong. The original function is actually 3 ln x plus 1 over x, so that would be a plus, that would be a plus, and hence that would be a plus, and we get the right answer. Now, where the curve meets the normal again is satisfied by whatever x solves this equation. We are asked for part II to show that it lies between 0.13 and 0.14. So what I'm going to do for this, again, you should be working down the page and not across the page, but I'm doing this so it all fits on one page here. This was D part I. I'm going to do part II beside it, but you should be working down the page in the exam. Now I'm going to define a function g of x to be equal to this thing here, 6 ln x plus 2 over x subtract 3. If I was to show that, if I want to show that there's a root between these 2 points, I could use the root theorem, okay, that says that if this function is negative at one of these points and is positive at one of these points, because it's continuous between these 2 values, there must be a root between these. So I'm going to work out g of 0.13. I'm going to type that into my calculator. So I'm going to type in 6 ln of 0.13 plus 0.13 plus 2 over 0.13 subtract 3. So I'm going to type in that and I get 0.27. 0.27. I'm going to do the same thing for 0.14 and hopefully I get a negative answer. And I do, I get negative 0.37. So I could use the change of sign theorem. Therefore, change of sign of function g and continuous, and therefore root between 0.13 and 0.14. And I'm done. Okay, next question. We've got our curve here, y is equal to this. We're told that the x-coordinate at a point P is that. So we know that x is 3. What happens when I put 3 in here? Well, I get ln 1, which is 0. So I know I can find that one out easily. The point P is x is 3, y is 0. Find the equation of the normal to the curve in that form. Firstly, we need to find the gradient of the tangent at that point. Use that to find the gradient of the normal. We've got a point that we can substitute in. We'll be able to find the equation. So, y is equal to ln a third x. dy by dx. What's that equal to? Well, remember the rule, if y is equal to ln of some function of x, then dy by dx is always the differential of that function inside the logarithm over the function inside the logarithm. So here the differential of this is a third over a third x. The thirds cancel and you get 1 over x. So what is in particular dy by dx at the value x is equal to 3? Well, it's equal to a third. Okay, I'm just going to rub this out over here. Okay, you should again work down the page. I'm going to work across just to save values. You know that the gradient of the tangent is a third, so you know the gradient of the normal is its negative reciprocal, which is negative 3. we've got a point on the line of the normal, we've got the gradient of the normal, we can use y subtract y1 is mx subtract x1. So y subtract 0 is negative 3, x subtract 3. Multiplying this out, y is therefore negative 3x plus 9. And our a is negative 3 and our b is equal to 9, the things we were asked to find, and we're done. And last one here, pause the video, have a go. Okay, part A, show that the point P lies on the curve. So what you can do is you can substitute in x is root 2 and y is pi by 4 and check they're the same. So for example, I would just say left hand side would be root 2, and I would say the right hand side would be 2 sine of pi by 4, which is 2 times sine of pi by 4 is root 2 over 2, and that's equal to root 2. That's the easiest way of showing that point lies on the curve. It asks you to show that dy by dx is 1 over root 2 at P. So we know that we know that x is equal to 2 sine y. Now x is the subject of the formula here, so we're not going to be able to work out dy by dx very easily. We're going to have to use the rule that dy by dx is 1 divided by dx by dy. Whenever we see y the subject of the formula, that's what we do. We differentiate both sides with respect to y here. So we get dx by dy is 2 cos y. So therefore dy by dx is the negative reciprocal of this, sorry, it's the reciprocal of this, not negative, it's 1 over 2 cos y. Just flipping this. And in particular dy by dx at the point P they're asking, the point P is root 2, so when x is root 2, well what is y? Pi by 4. So when y is equal to pi by 4, you sub in pi by 4 here, 2 cos of pi by 4, and you get 1 over root 2 as required. Next part, find an equation of the normal to C at P. Remember P is equal to root 2 pi by 4. In the form y equals mx plus c. Now, from part B, we have shown that dy by dx at the point P is 1 over root 2. So dy by dx at the point P is 1 over root 2. So we have a pair of coordinates on the line, and we have what dy by dx is. Well, therefore, the tangent has gradient 1 over root 2, but the normal must have gradient its negative reciprocal, which is negative root 2. So we can use y subtract y1 is mx subtract x1 for the equation of the normal. So in particular, y subtract pi by 4 is negative root 2 x subtract root 2. We want it in this form here. So y subtract pi by 4, multiplying that out would be negative root 2x plus 2. And making y the subject of the formula, y would be negative root 2x plus 2 plus pi by 4. And so m is negative root 2, and in particular the c thereafter is 2 plus pi over 4, and you're done. And that's everything with regards to differentiation, and in particular using differentiation to work out the equations of tangents and normals to the curve. So we've covered everything on differentiation in videos 1, 2 and 3. Video 1 was simple differentiation, video 2 was finding turning points, and video 3 was finding equations of tangents and normals to the curve. I hope you found this very useful in your revision for Core 3. Thanks for watching.